Okay guys, so here is a practice problem. A website that rents movies online recorded the age and the number of movies rented during the past month for some of their customers. The data are shown below and the best fit regression line is given with a B0 value of 21.472 and B1 which is minus 0.325. We're asked to use the values to use the estimated regression equation to predict rentals for all 6 ages. And the solution is here, but I'm going to walk you through how we actually arrived at it. Now, one little tip, if you see a little icon like this and you click on it, it allows you to copy the table, and you can either copy it into StatsCrunch or you can copy it to a clipboard. Copy it to a clipboard, it puts it on your clipboard, and then you can paste it in whatever document you want. So if you paste it there, then you have it. Alright, but I already did it here. So we wanted to calculate our values for y, estimated values for y, which is here. And in this cell, we have B9, which is going to be our B0, plus B10, which is going to be B1 multiplied by A2, which is the age, and then it kicks out what the calculated rental would be for that particular age. Now, if you notice, I have the dollar sign surrounding the B9 and the B and the 9, and that's because I am going to want to make life easier by copying this formula. Let me remove this. If I have the formula written there and I click on this and I copy it down, then what it does, it holds the B9 value for all of these coming down, because I wanted to reference the same B9 value as well as referencing the B10 values. So that's your Y estimated values, which are here. The first one is calculated manually by just plugging in the value of X right here, and then you can either do it in Excel or do it manually here. The table they have shown has the completed value, and we also generate those values in Excel here. So the next thing we want to do is to find the residual ease. So that's the actual y minus the estimated y, and then that's done pretty simple here. I'm subtracting the actual y minus the estimated y, which is being done here as b2 minus c2, and again I copied this formula down to all of these cells. So all of these are the corresponding b3 minus c3 and so on. I didn't need to lock in a cell here because I wanted it to increment all the way down. So those are my E values, which the solution went on to find for one, and then it shows it for the rest of it. We wanted to also calculate the standard residual standard deviation, which is shown here. You sum the differences between the y and the estimated y's squared divided by n minus 2, and then you find the square root of all of that, and you can do that manually as it is done here to arrive at 1.07, or you can do it here. Now in this cell is what we found in this column is we found e squared by multiplying e by itself, so it's d2 times d2, and then that's done for all of these. So that formula is actually, that formula is actually copied all the way down here, which essentially means we are just multiplying e2 by itself, and then in this we're finding the sum, which is this part of the expression here. And in this is a very interesting expression what we're doing, if you look at it, we are wanting to find n minus 2. The n minus 2 is going to be the count of A2 to A7 minus 2. And then we're going to be dividing this sigma E2, which is here, which is in E8. So it's E8 divided by the count of A2 minus A7 minus 2. All of that I'm finding the square root, so I raise it to the power, and that's how you raise it to the power, with a little caret, which is above the number 6 key. And then you do a 0.5 to get a square root. Alright? And you end up getting this. This value here is not estimated, or not rounded off to 2 decimal places, which when you do it will become 1.01 and do U 6. So it's a little different from what the text gives here, because the approximations are different, but essentially this is how you would do it manually, and if you're comfortable with that, then knock yourself out, and this is how you would do it using Microsoft Excel. Alright, thank you. This is Rohan. Thank you for watching.